702 and Cape Talk.
The Naked Scientist.
Good morning, Chris. Are you well?
I'm very well, thank you, Eusebius. How are you?
I'm good. My body clock seems to be working.
Brilliant link there. Would you like me to talk about this amazing story, which I interviewed the lady Rosemary Brown, who published this paper this week, earlier in the week? Because I've been fascinated by the body clock ever since I started flying internationally to go to various events and suffering from jet lag. But actually, I got interested a bit before that because one of my friends at university was working on the body clock when he did his PhD. What is the body clock? Well, it's the fact that every single cell in your body, almost without exception, knows what time it is. And you think, why does that have to happen? Why does that matter? Well, it's so your body can gear its metabolism, it can gear its activity, it can gear when it grows, it can gear when it kills cells, it can gear when it grows new cells. This has to happen at just the right time for optimal health. There's no point in having your metabolism thundering away at night time when you're sleeping and then being really sluggish during the day when you're trying to do stuff. So time is really critical. And our timing in our body is set by the sun, and it sets a master clock in the brain, and the brain then sends signals to every single part of the body, syncing up those clocks. So if we could work out what time those clocks are saying it is, then we know we could optimise healthcare for people. We can work out whose clock is off kilter because we know that certain people do suffer from clock disorders. We can also work out when best to give drugs because, believe it or not, vaccines given at some times of the day work much better than vaccines given at the same vaccine given at a different time of the day. Certain people will make more antibodies if they have a flu vaccine in the morning than the evening. Chemotherapy will cure cancer better at some times of day than others. The problem has been, though, to measure accurately the time of a person's body clock, to know when to make those interventions, has been really tricky. You had to take blood samples from a person every hour, on the hour, and then do this very complicated test of the genes that are turned on and turned off in those cells. So this week in PNAS, what researchers in America have done, this is Rosemary Brown's paper, they've taken a large group of people, they've taken blood cells, just from a simple blood draw, and looked at the genes which are turned on in those blood cells. And what they're inferring is that when the body clock ticks to a certain position or a certain time, it will have turned on certain genes, turned off other genes. And if you measure those genes and you know what their relationship is to each other, and they've used a complex computational self-learning algorithm to do this, you can actually get a really accurate time for the person's body clock to within an hour or so, which is really very good. So they've actually published the algorithm and it's in the public domain now, so other scientists can begin to use this and shown how it works. And it looks like we'll now be able to take a simple sample of blood. In fact, you need 2 samples of blood about an hour or so apart, and you can tell with very high accuracy the time of that person's body clock. So you can then begin to ask important research questions, but also optimize their medical care potentially as well. Amazing, isn't it?
Beautiful. Absolutely stunning. That's really, really interesting. Kolani, good morning to you. Welcome.
Good morning. Yeah, my question is, please tell me, on Earth we have layering, like we have the crust, the mantle, and the core. Now, does Mars also have that, those lower surface? Does it have any layering?
Okay.
And if so, what layering is it?
Okay, interesting question. Did you hear it sufficiently clearly, Chris?
It's not a very good phone line. Could you summarise for us, please?
Yeah, he said that the Earth, we know, has got many layers, the crust, the mantle, the core. Do we know anything similar about the layers below the surface of Mars?
We know a bit, but not as much. The reason we know so much about what's inside the Earth is because for almost 100 years or so, scientists, including one Croatian scientist called Mohorovičić, Moho for short, because it's a hard name to say with all these itches on the end. He did amazing maths.
I was wondering what's happening there to you.
Mohorovičić, is to give him his credit, was a fabulous mathematician and actually was able to use seismic waves. So when there's an earthquake somewhere on Earth, the waves from the earthquake go travelling through the Earth and they reflect off certain layers inside the Earth. And so if you record those waves and when they come back and how they're reflected, what doesn't get reflected and what does, and there are different types of wave that travel from earthquakes, and you can use the different types to do this, you effectively are scanning the Earth. And that's how we know that the Earth is a bit like an onion with different layers inside it, because people have made these sorts of seismic measurements. Now, we haven't had the opportunity to do that for other planets in the same way. So there isn't the same detail. But what we can infer about other planets, we know because we can model them what they must be made of. So we know that Mars is a rocky planet. We know it has volcanism. It's got one of the largest volcanoes in our solar system, if not the largest, Olympus Mons, more than 20 kilometres high. So we know Mars has broadly a similar sort of structure to the Earth, so we can infer some things about it. We know that the gas giant planets like Saturn and Jupiter, for example, they have a very different composition to the Earth. So we have some idea, but we have the most detail at the moment of our own planet just because we've used things like earthquakes and a lot of recordings to give the Earth a very detailed in-depth scan. In the future, I think this will change because we've got probes out there now which are orbiting these bodies. They're making measurements. They're using things like the magnetic field. They're doing things on the surface like the rovers that are on Mars to work these things out. But at the moment, our level of understanding of the interior of these other bodies is more limited.
Brenda, good morning. Welcome to the show.
Good morning to you, gentlemen. I'd like to ask Chris, the Hubbly Bubbly, does it have adverse medical implications? Because I notice a lot of young people are using it and sharing the same mouthpiece.
Hello, Brenda. So for people who are not familiar, these are also known as hookahs and hubble bubble pipes. The idea is you put tobacco at the top, which you burn, and as you draw on the pipe, which is in a water bottle, it pulls the smoke through a water bottle, displacing the smoke through the water and then up into the mouthpiece. The rationale for doing this being that it cools the smoke, which can improve the experience. It also removes some of the water-soluble, more sour odours, which make the smoke apparently taste nicer. I've not done this because I don't like smoking. Some people do subscribe to this. That's their choice. You're right to worry about certain aspects of this. One, smoking is always bad. It's the worst thing you can do from your health. And it's not just me on a soapbox saying that. Epidemiologically and statistically, there's nothing really, apart from jumping off a building, that you can do that's worse for your health than smoking. Smoking causes cancer, but it also means it causes heart disease and strokes. Most people don't live long enough to get cancer because they've already died if they smoke. It takes a good 10 years off your life. Wow. So first thing, if you want to smoke, that's your choice, but you'd be strongly advised, if you care about how long you want to live for and the quality of your life, don't smoke. The second point is that, as you highlight quite accurately, people often share the mouthpieces, and there are infections that can be spread by saliva. The common ones are things like hepatitis B, but also more mundane things like herpes simplex virus that causes cold sores. You don't want that. And the common cold. All these things go in saliva. So you could transmit them, but then at the same time, you could say, well, I won't kiss someone then. So you've got to be sensible about this. And so have a careful choice about who perhaps you share one of these things with, and if you think it's really worth the experience. But on the whole, really, I think the saliva risk it pales into insignificance against the risk of smoking. It's better not to smoke.
Thank you so much for your question, Brenda. Much appreciated. Andrew, good morning.
Hello, Julius. Dr. Chris, I have a cavity in my tooth. Now, what I've noticed is that when I drink cold water, it gets painful, but when I drink beer, I don't feel any pain at all. So why is that happening?
Is your beer warm?
Sorry?
I'm joking. I assume you mean cold beer doesn't have the same effect.
No, cold beer doesn't have the same effect.
Okay.
I don't feel anything at all. Yeah.
Oh, that's interesting. Chris?
Well, I think probably when people complain of sensitive teeth, they tend to say that cold things are excruciating, whereas warm things are less of a problem. It's probably because the temperature difference between your body temperature, which is at 37 degrees, and a hot beverage, which might be, say, 45 degrees, that's only maybe 10, 15 degrees temperature difference. When you drink a glass of icy water, that's at nearly zero. So that's almost 30 degrees or more of temperature difference. So it might be that it's just the temperature difference and therefore the scale of the effect that you're feeling. It's also possible that the cold water actually cools the tooth around the cavity for a bit longer, or you get some ice on the surface, or you're also initiating other things like an ice cream headache at the same time as the sensitive tooth, and that's why you get a whole bunch of symptoms all at once, which makes you notice it more. I suspect that's the reason. But if you have a cavity in a tooth, you're going to allow more thermal flow between the sensitive nerves in the dentine inside the tooth and the outside world. So you're going to notice temperature differences more, but I suspect the reason you're noticing the cold more is, as I said, the difference in temperature between icy water and body temperature is greater than the difference in temperature between body temperature and a hot beverage.
Terry, welcome to the show. What is your question for Chris?
Good morning to all. I got a quick one. My wife was in the UK and she saw a health magazine, an article in Health Magazine about baking powder, about cleaning vegetables and so forth with baking powder. And it was on, it says the effect that water or bleach, a thin bleach, getting rid of 13 potential harmful pesticides with 1% baking powder to water for 15 minutes. Chris, I'd like to get your opinion on, is that a fact or is it just someone trying to sell baking powder?
Well, baking powder is really cheap. It's sodium bicarbonate, which is a very weak alkaline solution. I've not seen the report in question, nor have I seen any evidence or claims that this is the best way to remove residues from the surfaces of fruits and vegetables. It's certainly true that you should always wash with fresh water things that you buy that you haven't grown yourself. Even if you have grown them yourself, you should always wash them off because there may be pesticide residues. There may also be other residues. Sometimes in certain places, many places, in fact, they use something called night soil in order to encourage the growth of plants. Night soil, for those who might not be wanting to hear this, eating your breakfast, night soil is sewage. It's full of rich things like phosphorus, so it's great for soil enrichment, but there are microbes in there which can stick to the surface of the fruits and vegetables. They can also get embedded in the flesh of the fruits and vegetables, and if you don't wash them carefully and if you don't peel them, which is probably the best advice, peel it, boil it, or leave it. It's the traveller's advice, isn't it? Then you could pick up those microbes. I don't think a weak solution of baking powder, given that it doesn't do you any harm, it doesn't seem to do your microbiome any harm when you eat it, and your stomach acid is really powerful anyway. I don't think that the bicarb is going to make a huge difference. I think just washing things with running water, clean water, not too much clean water, just a bowl to swill them around is probably adequate to dislodge these chemicals.
Interesting question. Nigel, good morning.
Good. Hello.
Go ahead, we can hear you, Nigel.
Thank you. Chris, 702, thank you for taking my call. Chris, I just wanted to ask you, to your knowledge, have any two human beings ever been found with the same fingerprints?
An old chestnut, Chris.
Do you mean genetic fingerprint or do you mean physical fingerprint? Or perhaps we could possibly talk about both. The answer is no, but then we haven't scrutinised the entire human race, have we? So it's perfectly possible, I'd say, that there will be some people with extremely similar fingerprints, but when you're talking genetic fingerprints, the answer is both yes and no. Genetic fingerprints are absolutely unique, and you have 3 billion genetic letters in your DNA code, but if you have cloned yourself, otherwise meaning you have a twin who is an identical twin, you do share a genetic fingerprint. Your fingerprints, though, physically, although your genetic fingerprint will be the same, your physical fingerprints will be slightly different because your fingerprint comes from random changes that are imparted during embryonic development, which gives your fingers their own unique pattern. Your genetic fingerprint doesn't vary from the minute you're conceived.
702 and Cape Talk.
The Naked Scientist.
24 minutes after 10. Brian, welcome to the Naked Scientist. Go ahead, what's your question?
Yes, good morning. Hi, Chris. Excuse me. Coming back to the subject of microbiomes, you probably read the recent study on probiotics coming out of the Weizmann Institute, which basically questions the usefulness of probiotics as a regular food supplement, but more importantly, questions the efficacy of doctors prescribing probiotics in, should we say, conjunction with antibiotics, not so much in conjunction, but after treatment with antibiotics to repopulate the gut flora. I wonder what your take on this research was.
This is a tricky area. What we do know for absolute certain, and when we say probiotics are foods or things that contain microorganisms. So, for example, yogurt has got lactobacilli, bacteria that like to eat lactose sugars. In there, they're viable, they're live, and the rationale for eating these things is that they go through your stomach, into your intestine, and they populate your gut with so-called good bacteria and make a good contribution to your microbiome, the population of bugs that live in you and on you. Now, when we're born, this process is absolutely fundamentally critical to you establishing a healthy life, because you pick up your microbiome from the bugs that you get from your mum as you exit her at the time of birth. So babies do pick up bugs by mouth and they populate their guts with them. What we're less clear about is how that changes as we get older. We know that when you become unwell, your microbiome does go off kilter. So if you eat some microbes in some of these food products and yogurt drinks and things you can buy, does doing that actually help to reset the balance? It's tricky. Scientists have looked at this and they have some evidence that enough bugs do survive the stomach acid in order to populate the gut. Whether or not they make a meaningful difference to the outcome for diseases like if you have an upset stomach and you take some in the short term, or if you have a chronic upset stomach and you take some, we don't know for absolute sure. People have done a number of studies on this and they've got mixed results. The thing is that for every set of studies you do, there will be some that show a positive benefit, some that show a negative benefit. So at the moment, the evidence is these are not doing people any harm. The evidence is therefore that if you do this, you're not going to harm yourself and you may have some benefit. So people aren't saying don't do this, but we're certainly doing more studies to try to find out whether or not this is as beneficial as we hope it can be. And also whether or not we might be able to make it even more beneficial by doing things slightly differently. One of the big revolutions in the last 5 years or so, 10 years, has been the concept of the transfusion. The idea that if you have an upset bowel flora with conditions like C. diff, your life can be saved by recolonizing and repopulating your intestine with the right sorts of bugs from a poo donor. We know those bugs can get in, flourish and save lives. So we know there's merit in doing this kind of thing. It's the route of administration and the sorts of bugs that you need to give and when. That data are still being explored and ironed out. So watch this space. It's certainly an interesting time.
Fascinating. Ntombi, good morning.
Hi, Mrs. Ntombi here. I just want to ask Dr. Chris, because I heard him talking about the body clock. I experience when I don't set my alarm clock for the following morning, and I just tell myself that I'm going to wake up at 4 a.m. I automatically wake up on my own. Is that part of the body clock, or like, what is that?
Lovely question.
It is a lovely
Chris?
question. And yes, it is part of your body clock. Humans are creatures of habit. And so if we get into the habit of going to bed at a certain time, we feel sleepy at a certain time, we sleep for a certain time, and then we wake up at a certain time. It's slightly more unusual to be able to say, I want to wake up at 4 o'clock and pre-plan your body clock to do that. But if you've done that for a number of occasions and you've got into the habit of doing that, because time is so important to your body, it's perfectly reasonable that that's going to happen. Regularly, I wake up during the week at, say, 6:30, 6:45 to get my kids up and get the kids off to school. Then along comes the weekend and you think, bliss, I'm going to have a lie-in. And of course, Saturday morning, you're awake at 6:45, even though you don't have to be. For the simple reason, you are a creature of habit and your body clock has been pre-programmed like it's got an alarm hand on it to wake you up at that time, because it knows that normally during the week your metabolism's geared up to get going 6:45 in the morning, so it wakes you up at 6:45 in the morning. And that's why we're successful as a species, because we're creatures of habit that can learn and adapt and then rinse and repeat.
Brian, good morning.
Good morning. You see, this will be very quick. Okay, so for the past almost a decade or so, I've been sort of convening in my sleep, like maybe 10 or 11 o'clock. When someone wakes me up, I'll be able to speak with them and have like I'm speaking to you now, basically. But when I wake up in the morning, I've forgotten everything, what I've said and what we've spoken, and this has been happening almost all my life. So I'm wondering what causes it. Is it because I'm right-handed and left-footed, and both my spheres are working? I don't know. Maybe the naked scientist can. Yeah.
Hi,
Thanks,
Brian.
Brian.
You're not alone, actually. Lots of people actually have this experience, and I have great fun. When I tuck my kids in at night, I will go and see how much of a conversation I can have with them, and it's great fun. You should try it. Not with my kids, obviously, but go and find some kids or someone else to try this on. The reason it happens is that when we go to sleep, sleep isn't just an on-off state. as you go through the night, sleep evolves, and what you do when you go to sleep evolves. So when you first drop off to sleep, you go into very deep sleep, but then you have these periods of near awakening. The brain becomes extremely active, and those periods of extreme activity become longer as the night goes on. If you look at a person who's doing this, you'll notice their eyes are moving a lot beneath their eyelids, and that's rapid eye movement sleep. They're dreaming at that time. So the brain has revved up its activity. We don't know why we dream, but we know those dreams become more sustained and more complex and richer as an experience as we go on through the night. If you wake someone up when they're in the middle of one of those dreams, they will often paint this picture of what they were doing or what was happening in their dream. They can recall it. But come the morning, they'll not be able to recall any of those dream states that they had during the night. So there's some process whereby, although you're having all these experiences, you just forget them. Now, when someone comes along and disturbs your sleep and talks to you, you're in one of those phases probably, which is why they've been able to rouse you and get you to talk to them. But because the mechanisms that suppress memory and you don't consolidate remembering your dreams are still in play, you don't really remember any of that sort of conversation, except perhaps vaguely remembering that you said something really rather daft, which is why I do this to my kids, because they come out with absolute rubbish, but it's hilarious. So just reassure yourself you're making someone's day when they have a conversation with you at night.
Stunning. Chris, we'll do it again next week. Have a lovely weekend and week ahead.
Thanks, everybody. Have a great weekend and see you next time.